So this is the exercise chemical energetic 2. First, question 1. Sulfur tetrafluoride, which is SF4, can be made by combining a gaseous sulfur with fluorine. And the reaction is exothermic. We have to complete the energy diagram for this exothermic reaction and include the arrow which clearly shows the energy change. Because the reaction is exothermic, so exothermic reactions, the reactants have high energy and the product is having low energy. So when we draw, this should be the product which is SF4. And because we have to draw an arrow to show the energy change as well. So energy change for exothermic reactions, energy change is always the direction, the arrow which we use to show energy change, that should always point downward. If it was endothermic reaction, the energy change arrow will point up. And they did not ask here to mention activation energy, but some question they asked to label activation energy as well. So we'll draw a peak where when it reaches activation energy and form a product. So we'll draw a vertical arrow which is pointing upward, and that is labeled as a activation energy, the minimum possible energy we need to start. And energy change is represented by delta H. And SF4, yeah, it's in a gaseous state, so we should write the state as well. That's right. So the first, like why it's of 3 marks. 1 mark when you draw an arrow correctly, even not only like the direction of the arrow is also the important thing. So exothermic reaction, the first 1 mark is for the position of a product that should be below the reactant. The second mark is for the labeling a product. If you write SF4, it's fine. If you write SF4 and its state as well, that is also fine. And the third one is the direction for the energy change, the arrow for energy change, which will point downward. The next question, during the reaction, the amount of energy given out is 780 kilojoule for 1 mole. The fluorine-fluorine bond energy is 160. Use the information, determine the energy for 1 mole of SF bond. So the formula is that the bond breaking, and this is the reactant side. So reactant side is a bond breaking side. So reactant side, we break the bond. Product side is a bond forming side. The bonds are formed. And when we take a difference between bond breaking and bond forming, that is equivalent to energy change. So bond breaking minus bond forming equals to energy change. So bond breaking energy, sulfur, because it's an atom, so there is no bond breaking energy. Because there is no bond here, it's an atom. For fluorine, each fluorine, it is 160. So this is 160, this is also 160. The total bond breaking energy is 2 into 160. Minus the bond forming energy, 1, 2, 3, 4. So there will be 4 SF bonds are formed. That's why 4 into SF equals to energy change. What is the energy change? It is 780. But because this energy is given out, so the energy change should be negative. As it's an exothermic reaction, the energy change is negative. For endothermic reaction, the energy change is positive. So bond breaking minus the bond forming equals to energy change. Now we simplify this. So 2 multiplied by 160, that's equal to 320. Minus 4 into SF is equals to minus 780. This 320 is positive. Other side, it will move. It will become negative. So it is minus 4 SF is equals to minus 780 and minus 320, which is equals to minus 1100. So minus 4 SF is 1100, but we need for 1. So minus 4 is multiplied, other side will be divided. So SF is equals to minus 1100 divided by -4, which is equals to 275. So 275 kilojoule per mole is the energy for SF bonds. In question 5, the bond breaking is endothermic, where bond forming is exothermic. Bond energy is the amount of energy that is needed in kilojoule per mole for 1 mole of a specific bond. The bond energies are given to us. These bond energies are given to us. The bond breaking energy is given, the bond forming, and then we have to work out the total energy. The bonds which are broken. So which bonds we are breaking here, you have to identify the difference. The total bonds which we are breaking.
4CH
So there
and
are,
ClCl.
yeah. So we have, like, because the reactant side is a bond breaking side and the product side is a bond forming side. Even this question you can solve. There are two ways to solve such question. Like, I can consider all the bonds or I can only consider the difference. Like when you check the reactant and the product, what difference you observe? Like these three CH bonds are same. I can solve in both ways. So I will solve both ways. This question, like this three CH bonds look same before and after. So means this bond neither form nor break. So what difference is there? There is one, this CH bond. Now it becomes Cl bond. So mean that is a difference. Then there is a Cl bond and HCl bond. That is also a difference. So if I write here, like if I only write CH bond and I write ClCl, so CH bond energy is how much? 412. And ClCl bond energy is how much? 242. So total energy is how much? This will be 4, 5 and 6, 654. Same thing, the bonds which are formed. This is one way of solving such question. Like instead of taking all the bonds, I just work out the difference. Like which bonds are different in reactant and product. So one way, like I took CH here and then I took ClCl. So CH is how much? 412 and Cl and Cl is 242. Yeah, you can solve in both ways. That's why I'm saying this is one way. There's another way that we consider all, because the reactant side is a bond breaking side. So usually, so whenever you're solving such question, you should consider all the bonds which you break and all the bonds which are formed. But I was giving another way which you can also use to work out the answer. That is, you work out the difference like 1, 2, 3 and 1, 2, 3. These all three CH bonds are same, identical. So which bond is different here? This bond is different. Like here it is CH, here it becomes CCl. So means this bond break, this bond form. And then there was ClCl, and then it become HCl. So what I can do, I can just take which bonds are different in reactant product. So that bonds will break like CH. So CH is how much? 412. And ClCl is how much? 242. So this was 4, 5 and 6, 654. Then bond form, if I take only CCl, so carbon and chlorine bond, that is 338, and H and Cl, That is 431. So this will be 9, 6, and 7. So 769. When I take a difference between the bond breaking and the bond forming. So what is the difference between bond breaking and bond forming? How much is the difference between them?
So Mr. Negative 115.
So negative 115. So you will get minus, because bond forming energy is more, so the final answer will be minus 115. Or you can easily work out the bond breaking energy is less than bond forming. That's why this reaction will be exothermic. So you can work out by the differences, like how much difference is there in the bond breaking and bond forming. Or second way, which we usually do, we work out the total bond breaking energy, like the reactant side, the bonds will break, and the product side, the bond will form. So bond breaking minus bond forming give the energy change. You will get the same answer. It won't make difference. It will also be minus 115. Is it clear, this one?
Yes, sir, clear. But sir, I didn't calculate the energy change.
You have to calculate the total energy, that is the energy change, by taking a difference.
Sir, is total energy like for the bond breaking and bond forming, or for energy change?
No, because you have to show that this reaction is like bond breaking is there, bond forming energy is there, and you have to identify that what kind of reaction is this. So like you can mention that bond breaking energy is bond forming energy is more than bond breaking. They did not ask for internal energy, so internal energy is not having mark, but you conclude that because the bond forming energy is more, so this overall reaction will be exothermic. Then the next question number 7. About the type of reaction, Rafe, because this question I did not copy it fully. There is more parts are there in it, in which they ask identify the type of reaction, whether it's endothermic or exothermic. So in the exercise, because of the space, I only copied uh, the part which is related to calculation. But there was, in actual question, there was a part in which they asked identify what kind of reaction is this. In question 7, the reaction of these metal with oxygen is exothermic. Give an example of a bond forming. So reactant side is a bond breaking side and the product side is a bond forming. So which one is a bond forming side? So the bond forming side is the product side. So give an example of bond forming in this reaction. So that's a bond form between barium and oxygen. So the formation of a bond between barium and oxygen is an example of. So here you can write the formation of a bond between barium oxide, because that is a bond forming side. Explain using the idea of a bond breaking and bond forming why this reaction is exothermic. Because it's an exothermic reaction, how you score 3 marks. So you'll mention because the bond breaking energy is less than bond forming, or bond breaking energy, the energy needed to break the bond is less than the bond forming energy, the energy released when the bonds are formed. That's why the reaction will be exothermic, or bond forming is more than the bond breaking. And in question 8, exothermic reaction produce heat energy. An important fuel is a methane, which is a natural gas. In chemical reaction, bonds are broken and new bonds are formed. Use this reaction to give an example, the bond which are broken. So which bond we break? We break CH bonds, because CH4, In the reactant side, we have CH4. So there was carbon bonded with 4 hydrogen, and there is the oxygen-oxygen double bond. And the product side, we have carbon dioxide plus water. So example, so you can write any of them. You can write OH, sorry, you can, because bond breaking side, so reactant. So you can mention oxygen-oxygen double bond is the broken, or you can also mention CH bond is broken. The bonds which are formed, that is oxygen and carbon double bond, or hydrogen and oxygen single bond, or OH bond. Then explain using the idea of a bond forming and breaking why this reaction is. It's the same thing that you will mention. The bond breaking energy is less than the bond forming. That's why overall reaction is exothermic. If it was an endothermic reaction, the bond breaking energy will be more than the bond forming energy. Some radioactive isotopes are used as a nuclear fuel. Give an example, give a symbol and a nuclide notation or nucleon number for isotope, so which is used as a nuclear fuel. So we use uranium 235. So uranium 235 is a nuclear fuel. Another uses of radioisotopes where we can use them. So we can use for treatment of a cancer, radiotherapy, for sterilizing the equipment, surgical smoke detectors. No, other than it's used as a nuclear fuel, so that is related to production of electricity. You have to mention other than production of electricity. Uranium, actually, uranium 238 is not a nuclear fuel. 235 specifically a nuclear fuel. So you should write one mark is for uranium symbol U, and the second mark is for 235. If you write 238, you will score 1 mark out of 2. Then next is question 13. In question 13, alcohol from a homologous series, the first 4 members are methanol, ethanol, propanol, butanol. One characteristic of these homologous series that the physical property is very predictable way. Like we can predict the next member, what will the boiling point, what will the heat of combustion. The first 3 alcohols are shown: methanol, ethanol, propane 1-ol, and butane 1-ol. The negative sign indicate that this reaction is exothermic. Higher negative means more energy is released. What form of energy is given out? So which form of energy the reaction gives out? So they give out heat energy. So you just have to mention here the which form of energy is given out, that is a heat energy. Is the reaction exo or endo? So how you can identify it should be exo. Why? Because first thing is a combustion. Second thing, you can see that the energy changes or the heat of a combustion or energy changes are all given as negative. Then complete the equation for combustion of ethanol. Look, for combustion equation, like for normal equation, the order is oxygen, hydrogen, and then the other element. But for combustion equation, if we want to balance them, we start with carbon. The order of balancing a combustion equation start with carbon followed by hydrogen and add the last oxygen. That should be the order for balancing a combustion equation. But first we have to complete a product, because when we burn alcohol, it's giving out carbon dioxide as there's a carbon present, and hydrogen is there, so it will give out water. That's a product. Now balancing. 1 mark is for the correct product, 1 mark is for balancing. First we start with carbon. There are 2 carbon on the left hand side, so we should have 2 carbon on the right, so we put 2, so carbon is balanced. Then hydrogen. 5 plus 1, 6. So we need 6 here. So we put 3. 3 multiplied by 2 makes 6. So hydrogen is balanced. Now about oxygen. 2 multiplied by 2, 4. And plus 3, 7. So there are 7 oxygen on the right hand side. So there should be 7 oxygen on the left. 1 is already there. So we need 6 here because 6 plus 1 makes 7. So 1 is already there. So what I should do? I should put 3 because 3 multiplied by 2 makes 6 and 6 plus 1 makes it 7. So this equation is balanced in terms of carbon, hydrogen and oxygen. So first we write a product correctly. Then we start balancing with carbon followed by hydrogen and at the last oxygen. No, you can start with any element. I'm not saying it's always a rule. It's just to make a balancing simple. These are the tricks we should follow. You should follow. Like start with carbon, make it then hydrogen, then oxygen for combustion equation. That make simple to balance. If you start with hydrogen or you start with oxygen, I'm not saying you will get a wrong answer. It's just like you may not able to balance it in a short time, right? So these are the tricks. When combustion equation, it's carbon, hydrogen, oxygen. When normal acid-base equation, it's oxygen, hydrogen, and other elements. This is a like graph is there. We have to plot a graph, determine the heat of a combustion of butanol by plotting a graph. What we have to do, like this is minus 700, minus 800, minus 900. So we actually work out the value like from the table. There are 5 lines between 700 and 800. So each line is representing 20. Means the first line after 700, the below the 700, minus 720, minus 740, minus 760, minus 780, minus 800. So these are the, so each line is representing 20. Now what we have to do, the values are 730, 1370, 2020. So we have to mark first the points. And from those points, we have to draw a straight line and work out the heat of combustion of butanol. I will plot the graph. So the first one is minus 730. So where I should have minus 730, like this is 720, this 740. So between them will be minus 730. Next, I have 1370. So 1370, this is 1300, this is 1320, 40, 60, 80. So this will be 1370. That's the second point. Then for 3 carbon, because here we have the number of the carbon 1, 2, and 3. For the third carbon is 2020. So it will be 2020 for 3 carbon. So 2000, like this one is 2000. And just the first line The first line after 2000, that will be equal to 2020. Now, what we have to do after marking the points, we have to just join these, like using a ruler scale. You just join these points. So using a ruler or the scale, you just join these points to work out the heat of combustion when four carbon atoms are there. So when four carbon atoms are there, how much is the heat of combustion? So this value. And you will check the x-axis, the y-axis. So like example, for me, it's coming out minus 2,600. So that will be, you will mention minus 2,600 accordingly. Or 6,040, 6,030. Yes.
Sir, in the table before, I found that I deleted the negative signs and I subtracted 1,370 minus 730. It gave me 640. Then I subtracted 2020 minus 1,370. It gave me 650. Then I added 2020. I added 660. So it gave me
Yeah.
negative 260, 680.
Yeah. So yeah, but the thing that's right. I'm not saying it's wrong because you have the table. You can work out from the table. But the thing is, you have to show this on the graph. Like using a graph, how you work out, you have to show this. Because if you read the question in the question they mention, normally student used to solve this question in this manner. But the question determine the heat of a combustion by plotting the heat of a combustion of the first three alcohol. So you have to actually plot them to work out. So you may lose here, like example, it's of 3 marks. So you will get the answer for negative minus, example, you write minus 200, 2,600. You will score 2 marks, but you will lose the third mark if you don't show this on your graph. The third mark is for showing clearly on the graph how you worked out. So how you show, like how you'll work out this. So when you draw a line and find the heat of combustion on y-axis, that will be the third mark. Is it clear?
Yes, sir, clear. Thank you.
Anyone else having a doubt or a question? Any other question or a part? So this was exercise 2 related to the chemical energetics.